Hi friends, today we're going to talk about solving by quadratic formula. This is specifically for quadratic equations that we have been asked to solve. So it would look like a second degree polynomial and there would be an equal sign, meaning that at the end our answer is going to look like something, x equals something, or a variable equals something. All right, first thing I want to put up is the formula, and that is the quadratic formula, which is what we're going to be using. It is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, let's talk about what those a, b's, and c's are. If I have a quadratic equation, it's going to be in the form ax squared plus bx plus c is equal to 0. And a, b, and c are the coefficients when everything is written on one side, and that is what we plug into the quadratic formula. Now, the quadratic formula just has to be memorized. You just got to memorize that one. Things that students often forget, well, the number one thing that they forget is that the division bar goes all the way across, that the negative b plus or minus the square root of b squared minus 4ac is all divided by 2a. That's the main one that gets forgotten. All right? Also, remember that the sign on a, b, and c goes with it. Now, we can use this to solve a quadratic. It doesn't work for something that's not a quadratic. So solve by factoring, well, that works for any degree of polynomial. This one only works for a quadratic. And I want to caution you, the only time you want to use this is when factoring and square root property won't work. Because there's a lot of places to make errors in the quadratic formula, and it's generally going to take you longer. So I want to say, use these first. Quadratic formula is your last resort. All right, let's look at an example. So if we want to solve a quadratic equation, that looks like 2x squared plus 3x minus 2 equals 0. All right, well, everything is already on one side. Our first step is taken care of. And now we can label our a, b, and c. So I like to just write above them a. So the a goes over the 2. B is over that positive 3, and C is over the negative 2. Don't forget to take that negative with you on the C. And then we will go back and plug those into the quadratic formula. So x is equal to, and that x equals to, that matters. So negative of b, negative 3 plus or minus the square root b squared. So 3 squared minus 4 times 2 times negative 2, all divided by 2 times a. Of course, a is 2, so 2 times 2. All right, so let me read that back. Negative 3 plus or minus square root of 3 squared minus 4 times 2 times negative 2, all divided by 2 times 2. All right, we've got it in there. We just have to evaluate now, or simplify. So negative 3 plus or minus 3 squared is 9. And then it's going to be a plus because negative 4 and negative 2 makes a positive number. 4 times 2 is 8, times 2 is 16. And then we'll be dividing that by 2 times 2, which is 4. So negative 3 plus or minus square root of 9 plus 16 divided by 4. All right. Inside that square root, 9 plus 16 is equal to 25. So negative 3 plus or minus square root of 25 over 4. Well, square root of 25 is just 5. So negative 3 plus or minus 5 over 4. All right. We have this plus or minus here. That means two different answers. So one of them is going to be negative 3 plus 5 over 4. The other one is negative 3 minus 5 over 4. All right, so negative 3 plus 5 is 2. 2 over 4 is 1/2. Negative 3 minus 5 is negative 8. Negative 8 over 4 is negative 2. So we have two answers, 1/2 and negative 2. Now this is a lot of steps to get here. So we want to be extra careful on those. And this is why I say if you are able to factor it, it's a better way to make sure you get the right answer. All right, let's look at another one. We want to solve. And I have x squared plus 2x minus 1 is equal to 0. Now, before I went to quadratic formula, I would want to look at it and make sure that I couldn't factor it. This one doesn't factor. So let's label our a, b, and c because they're all to one side of the equal sign. Now, on that x squared, we have a sneaky coefficient of 1. We don't write it, but that's the value of a that we will use in the quadratic formula. So a is equal to 1, b is going to be positive 2, and c is going to be negative 1. And I recommend writing that out every single time to keep you organized and make sure the right numbers end up in the formula in the right place. All right, so x equals opposite of b or negative of b plus or minus, so negative 2 plus or minus the square root of b squared, so 2 squared minus 4 times a, which is 1, times c, which is negative 1, all divided by 2 times a, which is 1. All right, so negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 1 divided by 2 times 1. Let's evaluate. All right, so negative 2 plus or minus, this will be the square root of 4 plus 4 over 2. So negative 2 plus or minus the square root of 8 over 2. We want to be really careful in how we simplify this. You might want to, if you struggle with these, look back at my video called the heart method. This will help you to evaluate these. All right, square root of 8, we can rewrite square root of 8 as 2 square root of 2. So negative 2 plus or minus 2 square root of 2 over 2. All right, then let's split it up. Negative 2 over 2 plus or minus 2 square root of 2 over 2. We can cancel a few things here. Negative 2 over 2 is negative 1. 2 square root of 2 over 2 is just going to be square root of 2. So my final answer would be negative 1 plus or minus square root of 2. All right. So quite a few things here. If you're not comfortable with evaluating square roots, there's a different video for that I'd encourage you to look through. And then the heart method for evaluating these binomials over a number. Let's look at one more. All right, this one we're asked to solve, and the equation is 2k squared plus 9k is equal to -7. Now the first thing I have to do is get everything on the left-hand side. So I'm going to add 7 to both sides and rewrite this as 2k squared plus 9k plus 7 is equal to 0. Now, when I look at that, I could factor it. But boy, it looks like a mess. So I'm going to choose on this one to go with quadratic formula. Sometimes that's just the choice we make. So I'm going to mark A is 2, this coefficient on k squared. B is +9, and C is +7. Okay? And so into the quadratic formula it goes. Now I chose to use a k here because I just want to make the point that here in the quadratic formula it's x, and we usually deal with x, but the quadratic formula works no matter what variable you have. So in this situation, it wouldn't be x equals, it would be k equals. All right, so k is equal to negative of b, so -9 plus or minus the square root of b squared, so 9 squared, minus 4 times a, which is 2, times c, which is 7, all over 2a, so 2 times 2. Notice that each time I write that b squared, I put b in parentheses. This is especially helpful if b is negative, to remember that we are squaring it, so it will end up being positive. All right, a little bit of math to evaluate this thing. So -9 plus or minus the square root of 9 squared is 81. Minus 4 times 2 is 8, times 7 is 56. So underneath that square root, we have 81 minus 56. And that's all divided by 4. All right, 81 minus 56 is 25. Square root of 25 is 5. So I'm going to rewrite this as -9 plus or minus 5 over 4. So this would be -9 plus 5 over 4 and -9 minus 5 over 4. So -9 plus 5 is -4. -4 over 4 is -1. -9 minus 5 is -14. Divided by 4 would be -7 over 2. So our final answer, k is equal to -1 and -7/2. Now, theoretically, I could have factored this one and gotten the exact same answer. And that might have been more straightforward. Either one would work. But quadratic formula, the best part about it, it always works, no matter what. So you will always get an answer. Even if it is a fraction or a square root or even an imaginary or complex number, quadratic formula will always give you answers.